Inductive charging.
Inductive charging uses an electromagnetic field to transfer energy between two objects. This is usually done with a charging station. Energy is sent through an inductive coupling to an electrical device, which can then use that energy to charge batteries or run the device. Induction chargers typically use an induction coil to create an alternating electromagnetic field from within a charging base station, and a second induction coil in the portable device takes power from the electromagnetic field and converts it back into electrical current to charge the battery. The two induction coils in proximity combine to form an electrical transformer. Greater distances between sender and receiver coils can be achieved when the inductive charging system uses resonant inductive coupling.
Advantages.
Protected connections, no corrosion when the electronics are all enclosed, away from water or oxygen in the atmosphere, safer for medical implants, for embedded medical devices, allows recharging powering through the skin rather than having wires penetrate the skin, which would increase the risk of infection. Durability, without the need to constantly plug and unplug the device, there is significantly less wear and tear on the socket of the device and the attaching cable.
Disadvantages.
Lower efficiency, waste heat. The main disadvantages of inductive charging are its lower efficiency and increased resistive heating in comparison to direct contact. Implementations using lower frequencies or older drive technologies charge more slowly and generate heat within most portable electronics. Slower charging, due to the lower efficiency, devices can take longer to charge when supplied power is equal. More costly, inductive charging also requires drive electronics and coils in both device and charger, increasing the complexity and cost of manufacturing. Inconvenience, when a mobile device is connected to a cable, it can be freely moved around and operated while charging. In current implementations of inductive charging, such as the key standard, the mobile device must be left on a pad, and thus can't be moved around or easily operated while charging. Newer approaches reduce transfer losses through the use of ultra-thin coils, higher frequencies, and optimized drive electronics. This results in more efficient and compact chargers and receivers, facilitating their integration into mobile devices or batteries with minimal changes required. These technologies provide charging times comparable to wired approaches, and they are rapidly finding their way into mobile devices. For example, the MAN Charge Vehicle Recharger System employs high-frequency induction to deliver high power at an efficiency of 86%, 6.6 kilowatts power delivery from a 7.68 kilowatts power draw.
Examples.
An early example of inductive power transfer is the crystal radio, which used the power of the radio signal itself to power headphones. Some such radios can use the power of a stronger station to increase the volume of a weaker station. Transcutaneous energy transfer (TET) systems in artificial hearts and other surgically implanted devices. Oral-B rechargeable toothbrushes by the Braun Company have used inductive charging since the early 1990s. Hughes Electronics developed the MAN charge interface for General Motors. The General Motors EV1 electric car was charged by inserting an inductive charging paddle into a receptacle on the vehicle. General Motors and Toyota agreed on this interface, and it was also used in the Chevrolet S10 EV and Toyota RAV4 EV vehicles. In 2006, researchers at the Massachusetts Institute of Technology reported that they had discovered an efficient way to transfer power between coils separated by a few meters. The team, led by Marin Soljasic, theorized that they could extend the distance between the coils by adding resonance to the equation. The MIT Inductive Power Project, called Wheatricity, uses a curved coil and capacitive plates. At the Consumer Electronics Show, CES, in January 2007, Visteon unveiled their inductive charging system for in-vehicle use that could charge only specially made cell phones to MP3 players with compatible receivers. April 28, 2009, an Energizer inductive charging station for the Wurr remote is reported on IGN. At CES in January 2009, Palm, Incorporated announced their new pre-smartphone would be available with an optional inductive charger accessory, the Touchstone. The charger came with a required special backplate that became standard on the subsequent Pre-Plus model announced at CES 2010. This was also featured on later XE, XE Plus, and Via 4G smartphones. Upon launch in 2011, the ill-fated HP touchpad tablet, after HP's acquisition of Palm Incorporated, had a built-in touchstone coil that doubled as an antenna for their NFC-like touch-to-share feature. In August 2009, a consortium of interested companies called the Wireless Power Consortium announced they were nearing completion for a new industry standard for low-power inductive charging called KEY. In January 2012, the IEEE announced the initiation of the Power Matters Alliance, PMA, under the IEEE Standards Association, IEEE-SA, Industry Connections. The alliance is formed to publish set of standards for inductive power that are safe, with smart power management and energy efficient. The PMA will also focus on the creation of an inductive power ecosystem. Intel and Samsung plan to launch key inductive charging devices for phones and laptops in 2013. Nokia launched two smartphones, the Lumia 820 and Lumia 920, on September 5, 2012, which feature key inductive charging. Google and LG launched the Nexus 4, which supports inductive charging using the key standard. Motorola Mobility launched their Droid 3 and Droid 4, both optionally support the key standard. On November 21, 2012, HTC launched the Droid DNA, which also supports the key standard. March 15, 2013, Samsung launched the Samsung Galaxy S4, which supports inductive charging with an accessory back. July 26, 2013, Google and ASUS launched the Nexus 7 2013 edition with integrated inductive charging. October 31, 2013, Google and LG launched the Nexus 5, which supports inductive charging with key.
Electric vehicles.
As mentioned above, man-charge inductive charging was employed by several types of electric vehicles around 1998, but was discontinued after the California Air Resources Board selected the SAEJ 1772-2001, or AVIN, conductive charging interface for electric vehicles in California in June 2001. In 2009, Avatron, a subsidiary of MTC Transformers, formally began development of plugless power, an inductive charging system they claim is the world's first hands-free, plugless, proximity charging system for electric vehicles. With the participation of the local municipality and several businesses, field trials were begun in March 2010, on the systems scheduled to be available in fourth quarter 2010. Researchers at the Korea Advanced Institute of Science and Technology, KAIST, have developed an electric transport system, called Online Electric Vehicle, OLEV, where the vehicles get their power needs from cables underneath the surface of the road via non-contact magnetic charging, where a power source is placed underneath the road surface and power is wirelessly picked up on the vehicle itself. As a possible solution to traffic congestion and to improve overall efficiency by minimizing air resistance and so reduce energy consumption, the test vehicles followed the power track in a convoy formation. In July 2009, the researchers successfully supplied up to 60% power to a bus over a gap of 12 centimeters. In one inductive charging system, one winding is attached to the underside of the car, and the other stays on the floor of the garage. The major advantage of the inductive approach for vehicle charging is that there is no possibility of electric shock as there are no exposed conductors, although interlocks, special connectors and RCDs, ground fault interrupters, GFI, can make conductive coupling nearly as safe. An inductive charging proponent from Toyota contended in 1998 that overall cost differences were minimal, while a conductive charging proponent from Ford contended that conductive charging was more cost-efficient. In 2010 onwards, carmakers are signaling their interest in wireless charging as another piece of the digital cockpit. A group was launched in May 2010 by the Consumer Electronics Association to set a baseline for interoperability for chargers. In one sign of the road ahead, a General Motors executive is chairing the standards effort group. Toyota and Ford managers said they also are interested in the technology and the standards effort. Daimler's head of future mobility, Professor Herbert Kohler, however, have expressed caution and said the inductive charging for EVs is at least 15 years away and the safety aspects of inductive charging for EVs have yet to be looked into in greater detail. For example, what would happen if someone with a pacemaker is inside the vehicle? Another downside is that the technology requires a precise alignment between the battery and the charging facility. In November 2011, the Mayor of London, Boris Johnson, and Qualcomm announced a trial of 13 wireless charging points and 50 EVs in the Shoreditch area of London's Tech City, due to be rolled out in early 2012.